be made n ways, right? Then those two decisions can be made in the m times n ways. Okay, I know, it makes no sense when we use that good stuff. Okay, but you're at the ice cream shop. Okay, you've got 3 size cones, you've got 15 flavors of ice cream, and you've got 8 toppings. Okay, and then it asks how many cones are possible if you get to only choose one size, one flavor, and one topping. Okay, well, how many sizes? 3 times how many flavors? 15 times how many toppings? 8. Boom. Multiply them. 360. So there are 360 different possibilities of different ice cream cones. Sweet. Might have to go there 360 days. Well, in a year, but this equals 360. Okay, everybody's got their calculators out? Mohammed, where's your book? Okay, then get a sheet of paper out and start writing. No being lazy. We have 4 days of instruction. Come on. Alright, so your science test has a section with 12 true or false questions. Oh, wait, we're on number 2. Sorry. A Virginia license plate consists of 3 letters followed by 4 digits. How many different license plate possibilities? All right, so this is where you have to be a little bit careful because it's not just 3 times 4 because it doesn't make sense that we only have 12 possible license plates. No. So we have to go each digit. So first 3 letters. Okay, so my first letter, how many possibilities? 26 or 27. There's 26 letters in the alphabet. Okay. Times my next one, how many possibilities? 26, because it's still letters. Okay. Times 26. All right, now we're catching on. All right, and then our digits. How many 1-digit numbers are there? 10, because you have to count 0. Because 0 can be on the license plate. So we've got 4 digits, so 10 times 10 times 10 times 10. And our license plate possibilities are 175,760,000.
Yeah.
Woo! That's fun. Okay? Alright, so next science test has a section with 12 true or false questions. How many different ways could you answer these questions? Alright, so you have 12 questions. Question 1, 2, 3, 4, 5, 6, 7. How many possibilities for section 1? 3, 2, 4. And how many of those are there going to be? 12. So it's going to be 2 to the 12th power. Would be a quick way to do that. 4,096 ways to fill out your 12-question true or false test. Craziness, huh? Bet you never thought of that before. All right, so we've got the Clayton family. They enter a 4-digit code. How many codes are possible? Okay, so the first digit has how many possibilities? 10. Second digit has. Third digit has. Fourth digit. So that's 10 to the 4th, which is 10,000 or 100,000? Okay. All right, so 10,000 different possibilities. Okay, so your little garage keypad, there's 10,000 different possibilities. Get into your garage. Alright, factorials. Okay. This is the product of all natural numbers from n to 1. Okay? And how we write this is it's n exclamation point. Okay? And what it means, okay, if I have 9 exclamation point, or 9, we call this 9 factorial, is how we say that, means that it's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, now, we're going to give you a little shortcut. Okay, if you have a graphing calculator, okay, you find your factorial key. Okay, so I would hit 9. And then your factorial key, you have to hit math. And then you have to go all the way down to this PRB, that means probability. And your factorial is 4. And you can enter. If you have a little calculator, come over yours. Okay, if you've got a little guy, nope. It's actually faster on a little guy. Okay, if you've got a little guy, it is, you would hit 9, and then it's this PRB button right here, and then you'd have to arrow over to your exclamation point. Okay, so if you don't have a calculator on your desk right now, I would get one so that you're not completely lost when it comes time to start entering this stuff in. Okay, let me see where. Alright, so this guy gave us 3, 6, what was it? 30. Awesome. Okay, so plug in your 12 factorial. Gave you oh, you guys told me million. 4 million?
No, 479.
479. Oh, I get it. All right. So 8 factorial. 40,320. All right. In this guy, you've got to put your bottom in parentheses. Okay. Or if we were to do this, okay, we'd have 17 factorial, so we'd have 17 times 16 times 15. 10, 9, 8, 7, 6, dot, 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 right? Okay, over 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4. Well, starting right here, what happens? My 11s cancel, my 10s cancel, my 9s, my 8s, my 7s. So all this stuff cancels. And I'm left with this guy right here. 17 times 16 times 15 times 14 times 13 times 12. Craziness, I know. Okay, or when you enter it in, just put your bottom in parentheses. So you're going 17 factorial divided by, and then put your bottom in parentheses. So 11. I wish there was a faster way to do it, but there's not. Factorial. Enter. 8, 9, what?
1, 0, 7, 1.
Like that? All right. Okay, our only exception to this rule is 0 factorial equals 1. All right. Permutations. Okay, these can be written as order matters. Okay, so the order in which we do things matters. Or the order that we put them in matters. Probably a better way to put that. Okay? So it is n factorial divided by n minus r factorial. Okay? N is the number of objects available, and r is the number of arrangements that we're going to make. Okay? Our shortcut, if we have n available and we're going to make n shortcuts, okay, then it's just n factorial. Alright, so let's make this make a little bit more sense. Alright, how many ways can we arrange the letters dinosaur? Okay, does order matter? It does, because if I use the D, I can't use the D again, right? That's why order matters. Okay, so in this case, how many different letters do I have? I have 8 letters, and making a permutation of 8, yep. Okay, so in this case, it's just going to be 8 factorial gives us how many different possibilities? 40,320. All right, so we have 7 students that are competing in a geography bee. How many ways can they finish in first, second, and third place? Okay, so how many people do we have available? So we make it 7 permutation of how many different places? 3 different places. Okay, so this is 7 factorial divided by, and then here is your number minus your arrangements, so it would be divided by 4 factorial. So enter that in. 210 different possibilities. Okay, now, you want a little shortcut for how to enter this? Yes or no? Yeah. Okay. Alright, so if you want to do that, alright, so in both calculators this works. Okay, if you have a graphing calculator or if you have a little calculator, it's going to be 7. Okay, if you have a little calculator, hit PRB. If you have a big calculator, hit math, go over to PRB. Okay, now, what letter needs to be in the middle? P, so we're hitting number 2, or for those of you with a little calculator, choose the one with P. Okay, and our second number is 3. Hit enter. Nice. Okay, so Melanie's taking 4 different classes this semester: history, algebra 2, AP English, and Chem. Okay, how many ways can these 4 classes be arranged on her schedule? Okay, so how many possibilities? 4. Permutations of how many classes? 4. So that's going to be 4 factorial. Gives us 24 possibilities of scheduling those 4 classes. Okay, number 8, how many available players? 16. How many are going to be in the lineup that day? 9. How many different possibilities for batting order could there be?
4, 1, 5, 1, 3, 4, 7, 2, 0, 0.
Lost me after 4, 1, 5, 1.
All right, 3, 4.
Woo! What is that? 4,151,347,200 different possibilities of a batting order? No, it doesn't seem like it could possibly be that much. That's crazy. Okay, we've got 28 students Okay, Mr. Miller's homeroom, so how many available? 28. P, and how many different representatives are we having? Just two, a rep and an alternate? How many possibilities are there? 756 possibilities. Okay, now, if there's, so right now we've got some overlap, right? For this? Yes, no? Okay, we have to divide out the overlap. So on here, how many different guys are there? How many different letters? Okay, so 10 factorial divided by, what are my, what overlaps? The O's, so how many O's are there? So divided by 2 factorial. Gives us I don't know the answer is. I didn't do this one. I'm getting a bunch of different ones. Remember, if you've got something on the bottom, you have to put it in parentheses. So 10 factorial divided by 2 factorial. Enter. Woo! We've got 181, 4400. Different possibilities to arrange the letters of automobile. Okay? This pair has how many letters? 9 letters. Okay? Divided by who repeats? The P repeats, so 2 factorial. Is there anything else that repeats? What? The A repeats, so that's 2 factorial. Well, no, you can't combine them. So what you have to do is you have to figure out what 9 factorial is. Come on, do this for me. The faster you, the more you guys put these in and tell me what answers are, the faster we get through this stuff. 3, 6, 2, 8. 8, 0 divided by, now you gotta go 2 factorial times 2 factorial. What do you get?
4.
Are you sure? Yeah, that would make sense because it's 2 times 1 times 2 times 1, isn't it? Yeah. So then you have to divide those guys out. 8,720. Okay? So far, so good? All right. Combinations. Okay, I like combinations better because order doesn't matter. Right? Order does. That's not how you spell does. Does not matter. Okay, and now this is n combination of r. My formula is going to be n factorial divided by r factorial times n minus r factorial. Okay? This time, that equals 1. Okay? There's a big difference between if it's a permutation, and we've got blank number of arrangements and possibilities, and if it's a combination. All right, so Natalie, she's got 16 close friends. How many ways can she choose 5 to be bridesmaids in her wedding? Okay, so now this is 16 16 combinations with 5 possibilities. Okay? Now, if you want to do it the long way, it would be 16 factorial over 5 factorial, 11 factorial. And nobody wants to do that, do they? Okay, so use those same buttons you did with your permutation, only choose the one with the C. 4,000 what? Okay, so 13, you've got 24 students in your kindergarten class. Apparently his mom's only letting him choose 8 to go to the birthday party. Sad. Okay. That's 24 combinations of 8. Most poor kids are getting left out. So sad for them. How many? 171. Okay. All right, so now we've got kittens. We've got 18 kittens at the pet store. She has a nice mom, and we're going to let her have 2. What do we got? Huh? 453. Really? That's all? 153? Oh, no, I gotta check on you guys. Is it 15? 3. Oh, no. 18. 2. All right, it's 153. All right, so we've got 12 employees at the sub shop. We need 4 working the Sunday evening shift. So we've got 12 combinations of 4. 400 what?
95.
95 possibilities. Holy, that's a lot of possibilities who could be working on a Sunday night. Sheesh. All right, so we've got 85 players on a football team. We got to choose 3 for a coin toss. $98,000 what?
770.
770 different possibilities of people that can do the coin toss. That's craziness. Okay? Alright, so now I think that this is the hardest. I think this part is the hardest part of what you have to do, is choosing whether or not it's a combination or a permutation. Okay, remember. Okay, so number 1, you've got 4 candy bars from a store that sells 30 candy bars. C or P? That's going to be C. Okay, 13 ways for students to line up for lunch. P, yes. Okay, and remember, this is just going to be your 30 C of 4. I'm not going to make you find all the answers yet. You'll have to do that on your assignment. Okay, this one would be 13 P of 13, which is your 13 factorial. Okay? How to make letters? That's always going to be P. Okay? 2 books from 40 books. C. 12 swimmers finished first, second, last, third. That's P. 2 students out of 27 to help. C. You have enough tickets to play 6 different games at the amusement park. If there's 4 different games, 14 different games, how many ways can you choose 6? This one's 7. Yeah, it is C. Which that one throws me off. I don't know why. Alright, how many different ways 9 different trumpet players to line up in a marching band? That's P. If they have to line up in a certain order, if you have to put something in a certain order, then it's got to be P. Okay, 7 students work together choose 4. C, yep. 18 offensive players in hockey. You need a left wing, a center, and a right wing. P, yeah. If they've got certain positions, you gotta go P. Anytime you're arranging a word, P. Choosing 5 goldfish out of 26. C. Okay? That wasn't so horrible.